Salam and welcome everyone. So today we're going to be working on the question on the screen that says a sample of 6.56 grams of argon occupies 18.5 dm cube at 305 kelvins. Calculate the work done when the gas expands isothermally in a reversible process, causing its volume to be increased by 2.5 dm cubed. So the first thing you have to do is you're told that a sample of a particular amount of gas occupies 18.5 dm cube. Now, the first thing you notice anytime in chemistry you're given the mass of something as well as the identity of that thing, what you're supposed to be looking for would be the number of moles. So just know you're going to be doing that in this question. And then you're telling you that occupies a particular volume. So this is V, and then at 305 Kelvin. So they have given us T. But then they say calculate the work done. So really what we're going to be looking for is work when the gas expands isothermally. So it's an expansion process. So we are going to have a V initial, which is this one right here. That basically what this one is in box. And then it said expands isothermally. So that is constant temperature. So constant temperature would also just mean like the change in temperature is zero. So during the entire process, the temperature is going to remain the same. So that's going to be this information right here. So in a reversible process. Now, this is the key to this question because it's possible for you to be asked to find the work done when a gas expands isothermally, either in a reversible process or against constant external pressure. But because we're asked in a reversible process, the formula we're going to be used will be specific to this question or to be specific to a reversible process. So that's going to be work done equals negative nRT ln V final divided by V initial. So so we have the number of moles to be mass of argon. Okay. So number of moles of argon equals to mass divided by molar mass of argon. So there's that. So yeah, that's it. So we have to determine that. We already know what the temperature is because we have that here. We have what the V initial is. We can determine the V final because it said causing its volume to be increased by 2.5 dm cubed. We can determine that as well. But let us first of all um write down all of the parameters before we start working with the work done equation. So we have number of moles of argon divided by mass. So that's going to be 6.56 grams divided by the molar mass of argon. And we know the molar mass of argon to be 39.948 gram per mole. So cancel out the grams, cancel out the grams. So the number of mole is going to actually equal 0.1642 mole. So that's basically what it is. And then you have the gas constant R, which is equal to 8.3145 joule per mole Kelvin. And you have the V final to be equal to change in V plus V initial. So V final is going to be change in V is 2.5 dm cubed because of course it's an expansion process, dm cubed plus the initial volume, which we have to be 18.5 dm cube. So the V final is going to be 21.0 dm cubed. So that's basically what the question is. Now, the last thing we have to do now is since we have the number of moles, the V final, the V initial, the temperature, the gas constant, we can just substitute. And that's basically how you solve a question like this. So W equals negative 0.1642. So that's mole, okay, times R, which is 8.3145 joule per mole Kelvin, times temperature, which is 305 Kelvin, ln V final divided by V initial. So that would be 21.0 dm cubed divided by the V initial, which is 18.5 dm cubed. So dm cube cancel out. So you have next W equals negative. We're going to cancel out all the units that we're not using because normally the unit for work is joules. So we want to make sure everything is in joules. So cancel out moles, kelvins. Kelvin, and now we just have negative 0.164 times 8.3145 joules times 305. We're going to get that to be negative 416.4327 joules times natural logarithm of 21.0 divided by 18.5. So that's basically, so work done now is going to be equal to negative 52.7853 joules. So that's going to be work done equals negative. So you have three sig figs for the mass. You have 360 for the initial volume, have 360 for temperature, and the final volume, when you add it to the initial volume, you end up with 21.0. That's also three sig figs. So this question is saying that we have to do it because that's how you do it in chemistry. Your calculation, you have to round it up or around it. You're just going to have to approximate to the sig figs that you're supposed to be using, right? So we are supposed to be using three sig figs here. So that's going to be 52.8, sorry, negative 52.8 joules. So this is basically the work for this question, the work done for this question. So you guys can see it's very easy peasy. So it just requires you to know the knowledge and for you to do everything step by step. I wish you guys all the very best. If you're trying to succeed and get an A in all your STEM related courses, make sure you email me at shuhabitutoring@gmail.com. I help students in high school, middle school, and college level, whether they require personal or group tutoring, to succeed and to get A's in all their STEM related courses. I wish you guys all the very best. If you have any questions, put it in the comment section. If you have suggestions, put it in the comment section. If you're just trying to book a session to check it out, make sure you email me at shuhabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.